let's look at one more thing, and actually what we're going to do here. We've been, for like the past forever, we've been finding zeros. Okay. Now we're going to do this. We're going to go backwards. We're going to take the zeros and go backwards and find the function. Okay. Yeah. Now this will actually be pretty easy. You'll like these questions. Okay. Now, first, before we actually do an example, we kind of got to go over something. Okay. It's called, and I'm not really going to quote the theorem. It's called the imaginary zeros theorem. Okay. So I'm not going to give you the fancy language behind it. I'm just going to give you like my version of it. Okay. So, and my version of it goes like this. Okay. Imaginary zeros occur in pairs. Okay. So it's impossible here to get just one imaginary zero. Raven, you have a question? All right. So imaginary zeros have to occur in pairs. So let me make a statement, an example of that. Okay. So if 3i is a 0, then I've got to have another 0 that pairs up with it, right? So take a wild guess as to the other 0, negative 3i. Okay. So if 3i is a 0, then negative 3i is also a 0. All right. Now, one other thing I have to kind of go over with you is the value of I squared, because we're going to see the value of I squared pop up. Okay. So let's look where I comes from in the beginning. We get an I from taking the square root of a negative. Okay. So -1, the square root of -1 would just be I. Now, what I'm going to do to this equation, I'm going to take it and I'm going to square both sides, just kind of randomly, so I can see what I squared would be. So let me square both sides. So this is going to give me I squared. Now, when I square this side, I'm not really squaring the -1. I'm squaring the square root. So what happens to the square and the square? Yeah, they undo each other, right? And so that would just leave me with -1. Okay. So when I see an I squared in a minute, what I can do is I can substitute -1 in place of it. So I squared is actually a real number, okay, because it's -1. Now, let's look at what we're going to do with this. And you can kind of see, I'm not going to write out the directions, but look at the bottom of the review. Okay. And I'm not going to do number 14 and 15, but I'll do an example like them. Okay. So at the very bottom, the directions on these are kind of confusing. Okay. It says find an nth degree polynomial function with real coefficients satisfying the given conditions. So it says nth degree, and it says right here n equals 3. So that means my polynomial is going to be something like x to the third power. That's all that that's saying. Now, and it gives me zeros here of 3 and 2i. So if 3 is a 0 and 2i is a 0, if 2i is a 0, then -2i is going to be a 0. Okay, and so what we're going to do is we're going to work backwards and find the polynomial. Okay, so let me give you one that's kind of similar, because those directions are a little bit intimidating, but this is not really a hard problem. I think I went the wrong way. All right, so let's say that the n degree of our polynomial is 3, and they're all going to be 3. Okay, I'm not going to make them really harder than that. And let's say that the zeros, let's come up with two different numbers. Let's say we have 4 and 3i. Okay, so if it's a third degree polynomial, I should have 3 zeros, shouldn't I? So I'd have 4, 3i, and -3i. Okay, so I'm going to write them out. 4, 3i, and -3i. And so now what I have to do to get the polynomial, by the way, we're going to put the polynomial in standard form, not in the factored form. But we're going to start with the factored form. So we're going to think, what kind of factors would give me those zeros? What, x minus 4 would give me a 0 of 4, right? Okay. And then for 3i, we say x what? Minus 3i, and then x plus 3i. And now all I have to do to get the polynomial is just take all this and multiply it out. Yeah, but that's a lot of work. And so that's all the thinking. Now the rest of it is just basic algebra. Now, here's what we're going to do with this. When we multiply out, we're going to multiply these two first because they're conjugates. Okay? So, right, when I multiply conjugates, we don't have to do first, outside, inside, last. We just have to do first and last. Okay? And so that's why I'm going to multiply these two out first. So I'm going to bring down x minus 4. Okay, so now first and last here, x times x is x squared. Right? Negative 3i times positive 3i would be negative 9i squared. Well, what did we say about that? I squared is negative 1. Okay, so right, it would be plus 9. And really what you could do is you could have skipped this step right here, and you probably just could have went straight to that. Now, y'all talk to me. Y'all understand here why this is x squared plus 9 now? Okay. Now all we have to do is just FOIL this out, and we've got it. Okay. So x times x squared would be x cubed. Okay. X times 9 would be 9x. Negative 4 times x squared would be negative 4x squared. Negative 4 times 9 would be negative 36. Now let's just put it in standard form. So it'd be x cubed minus 4x squared plus 9x minus 36. Okay. Now, notice what the other part of the direction said. It says what, use a graphing utility to check the real zeros. So I couldn't really check these two, but I could check this one. Now, how though? Right. And so, right, the graph should cross the x-axis at 4 and only 4, right? Because that was the only, so we couldn't see these two where it would cross these two because those are imaginary. So let's put our answer, what we got for our answer, in our calculator here. All right, so x cubed minus 4x squared plus 9x minus 36. All right, so we're going to zoom 6, and sure enough, the graph there crossed at 4, only 4. Right, because you can see the imaginary ones. All right. Now, all right, do y'all want to do another example? One more? Okay. All right. Let's try this one. Bless you. All right. Let's say the degree of the polynomial is 3. All right. And let's say that we have zeros of negative 2 and 4i. Okay. So if we have, what, negative 2 and 4i, that means we would also have negative 4i. Okay. So I like to write them out. Negative 2, 4i, and negative 4i. Okay. Now y'all could, y'all don't have to write that out. Okay. Now let's do our polynomial. So let's look at the factors that would give me that. Yeah, x plus 2. Okay. X minus 4i, and then x plus 4i. Okay. Now when we multiply it out, right, that just tells you the degree of the polynomial. Okay. So let me pose this question, and you're not really going to, I'm not going to give you a question like this, but I just want y'all to think, okay? If it said n equals 4, and it only gave you 2 of these, what would that really mean about the negative 2? It would be multiplicity. So you'd have to say x plus 2 times x plus 2. So that's what that's for, just in case you got some multiplicity in there. Okay. Now, ultimately, it's going to tell me down here that my polynomial is going to be x to the third, then something else. Okay. Now, when we multiply this out, we're going to multiply our conjugates first, aren't we? Now, let's skip a step this time. I'll bring that one down. So first and last here, this is just going to give me x squared. Now, negative 4i times 4i would be negative 16i squared. But I squared is negative 1. So it's really just going to be plus 16. All right, y'all need to see the step in between? No? Okay. Now, let's just multiply this out. So let's fold it here. That would give me x cubed plus 16x plus 2x squared plus 32. Okay, now I'm just going to put it in standard form. So x cubed plus 2x squared plus 16x plus 32. Okay, so when I throw it in my graphing calculator, I'm not going to do it this time, but if I throw it in my graphing calculator, we should see the graph cross at negative 2, and that's it. All right, now let's do this. I'm not going to go through and like work any of these. Now, of course, I'll have the answers for these tomorrow, okay? But let's just go through a few of them just to remind us about especially the older problems, okay? Now, yeah, like in behavior. And see, that's what number 1 is really asking about, is what's the in behavior, okay? So now this function has got the graph of negative x to the 8th. So what graph really gives me the in behavior? Yeah. What graph gives me the in behavior for negative x to the 8th? Negative x squared. Okay. Now, what does negative x squares do on the ends? They go down. So which one of these graphs is going down on both sides? Right, A. So you see how we didn't really do a question like this, but you see how you can answer that from the in behavior? All right. So, like, let's look at the other 3. What if I would have had, like, a positive x to the 6th? Right. So both sides will be going up. So that would be something like C. All right. What if I had like negative x to the 5th? All right. So that's, yeah, what, down, no, up on the left and then down on the right. So that would be like a D graph. Okay. Now, all right, let's look at 2 through 4 real quick. All right. It says sketch the graph of the polynomial function. Be sure to label all your intercepts. So let's talk about, there was like 4 things here that helped me sketch these graphs. Okay, what's the first thing? Somebody said it. Zeros. Okay. So zeros are the x-intercepts. So what are the other intercepts? The y-intercept. Now, how do we find the y-intercept though? Plug 0 in for x. So like on this one, it would be 8 times negative 2 times 6 squared, whatever that is. Okay. So we got zeros, the y-intercept. All right, what else helps me to sketch the graph? Yeah, in behavior. Okay, which in this case, this would be like x to the 3rd. So we'd be going down on the left and up on the right. All right. Now, what's the other thing? Multiplicity. Okay. So, like on this one, at 2, what would the graph do? Just, yeah, cross through it. And at negative 6, it would touch it and turn around. Okay. So that was with a multiplicity of even a multiplicity. Now, let's look at like this one. So what are my zeros on this one? What? 0. What else? 3 and negative 5. Okay. So what would it do at 0 with being to the 3rd power? snake through it. This one would touch it and turn around, and then this one would just go through it. Yes. Like it's like a piece of a parabola. You want me to draw that? What I'm talking about. So if we say like on number 2 at -6. So I'm not sure if it would go from the top or from the bottom. So it would do this. It would just touch it and turn around. Okay. Or it might do that. Okay. Yeah. But see, it's going to do other stuff though. Okay. Now, all right, let's look at the inequalities. All right. This one says you're going to solve it here by graphing. So we're going to graph this as a function and then write the solutions in interval notation. So we use all the same stuff, except for on these, you don't have to include the y-intercept. All right. So we're going to graph it. Now, how are we going to tell what the solutions in interval notation are? And keep in mind what it says there on number 5 is that we're looking for where it is greater than 0. So it's where the graph would be above the x-axis. Okay. Now, let's go back on 3 and 6 and notice something that you're going to have to do on those two. To get zeros, what are you going to need to do? Because factor them. Because notice what all the other ones, those were in factored form. So I mean, we could just rattle off the zeros, but these aren't in factored form. So you're going to have to factor them on those two problems. Okay. Now, let's look. All right, 8 through 10 now. Do we need to see one like one of those? Okay. All right, let me find the one that I did with first period or second period. Give me a minute. Of course, I can find every one but that. I'll just make it up. All right, let's try this one. Probably not going to have time there. All right, let's say, let's do 2x squared plus 12x is, or let me think about that. Let's say, make that 11x is less than 6. Okay, so we said we needed to factor it to get the zeros. What do I need to do before I start factoring those? Right, okay, so plus 11x minus 6 is less than 0. Okay, now let's factor it. Factors of 12 that subtract to be 11 would be 12 and 1. It would be plus 12 minus 1. Now let's group them. So we get 2x times x plus 6 minus 1 times x plus 6. So we get x plus 6 is times 2x minus 1 is less than 0. Okay, so what are my zeros that I can put on my graph here? -6 and 1/2. Now, how can I get the rest of the graph? What else do I need to think about? The end behavior. Okay, so it's x squared, so it's going to be going up on both sides. And now no multiplicity, so both of them is just going to cross through, and it's going to make a parabola somehow. Now, we're looking for where that it is less than 0. So less than 0 would be under the x-axis. So that would be in between -6 and 1/2. Notice I'm using parentheses because it's just less than. It's not less than or equal to. Now, what if we would have looked at greater than? Then it would have been, what, -6. I'm sorry, that's not right. -infinity to -6 union 1/2 to infinity. Okay. All right, does that kind of help y'all out on those now? Remember how to do them? So the graph solves the problem for you. The graph is not the answer, but the graph helps you to get the answer. All right. Now, we'll go over this tomorrow. I can if y'all want me to. I didn't have myself mic for half of it, but now I am going to do